All right, I have the unenviable task of following those two amazing talks. And they were expansive and global, and here we're going to bring things a little bit closer to home. And I'm going to focus on talking about the park's ambitious goal of reversing the loss of riparian wetlands that we've experienced over the last 100 years. And I say it's ambitious. I think it's pretty clear from this picture what I'm talking about. This is a spot in Kawanichi Valley on the west side of the park. Believe it or not, that red dot is the same location on each side of the map here. And you can see that over 60 years, we've totally lost a whole bunch of the beaver ponds, surface water, almost all the tall willow. And on the right side, you can see that it's just basically all gone. So in this spot and the valley it's in, Kawanichi Valley, we know we've lost 98% of tall willow over 20 years, ending in 2019. And we've also lost at least 55% of tall willow on the east side of the park. But really, these are the only places, this is just the places that we're looking and collecting good data. We know from observations on the ground that we've lost willow across the entire park. And the reason why we care about this, and Doug talked about this earlier, is that wetlands are biodiversity hotspots. They really punch way above their weight. In Rocky, it's only about 4% of the park, but we know that they support 65% of rare plant communities, 45% of passerine birds, and then 20% of the mammals use wetlands for some part of their life event. But also, it's just an important part of the National Park Service's goal is to preserve ecosystems, landscapes, species for current and future generations. So it's important that we keep these places in Rocky. The wetlands also have benefits for people inside and outside the park. They're beautiful places. They also can act as a fire break, which is top of mind this time of year when we are entering fire season. They hold water during drought, which can benefit lots of different wildlife species, but also can decrease the amplitude of floods. They also can act as a filter, which can increase water quality for the communities around the park. So there's all these benefits to people as well. And so I want to go into the ecological history that led to all of this wetland loss that we've seen. And to do that, I'm going to go through this relatively simple food web that we have in Rocky Mountain National Park, or that we did have. So I'm going to break it down into two big chunks. The first one is this side that's anchored by beavers. And beavers are these famously, they're famous ecosystem engineers that eat willow and aspen. They use it for food, but they also use it to build beaver dams. These beaver dams raise water tables, cause overbank flow, and that creates more willow and aspen habitat. So this creates a cycle, a positive cycle that allows there to be more beavers, and this continues and continues. And this creates, this feedback cycle creates more biodiversity, and it stabilizes these wetlands over long periods of time, and despite things like fire, drought, climate change. And what we've seen is that for partially because of direct trapping, but also because we've lost so much of the willow and aspen in the park, we have just a tiny fraction of the beavers that we had before the park was created. So we think that we have about 2% of the beavers remaining, maybe 1% of what we had historically. And that's created downward pushes on all of these other things. And the result is that we think we have lower biodiversity than we would have otherwise. So now over to the large mammal side of this food web. So we heard from the other talks that here we would normally have had these top predators. The other predators are important as well, but wolves and grizzly bears in particular, they would regulate elk populations. Elk do consume willow and aspen, even though grasses and to a lesser extent forbs are their primary food. But especially in the winter, they would eat those foods. But they wouldn't eat so much because their populations would be regulated by wolves. And what's happened on this side is we heard how Western settlers extirpated these top predators, and we lost that regulation of the elk populations. So elk are a key species in the history of the Estes Valley and Rocky Mountain National Park. So I'm going to talk a little bit more deeply about them. So a lot of people don't know that elk were locally extirpated. They were hunted to extinction because of market hunting for meat in this area. And then they were reintroduced in 1913, 1914. These are some of the elk that Doug mentioned that were brought from Yellowstone down here. And that was just the year before Rocky Mountain National Park was created. Then, just like in Yellowstone, we were seeing a lot of parallels between this story and the Yellowstone story. There was this explosion of the elk population to the point where the park started to have to do population control in the 40s and 50s and 60s. And that included some of the same tools of culling, but also trapping and moving elk to other places. And then park-wide, National Park Service-wide, we entered this period of where we had a paradigm shift in the management attitude, and we entered this period of natural regulation, where you just let ecosystems and ungulate populations in particular regulate themselves. And then just recently, we started the Elk and Vegetation Management Plan, which I'll get into in a little bit. But right in the middle of the natural regulation period in the 90s, we reached a situation where the population of elk, especially using the east side winter range, so these big valleys on the east side of the park, just gave plants in certain areas of the park a break. It just allowed them to grow without getting eaten so frequently. And people who've been in the park, who has seen these fences? Who has been inside these fences? Okay, yeah, I urge you to go in there because it is amazing what you can see. And it doesn't take much data to know that these fences are working. And this pattern, just the explosion of growth inside the fence and less outside, this strongly implicates herbivory as the driver of this landscape pattern. The other primary tool is elk culling. And the way that this worked is every single year we would do monitoring for the population and then cull based on trying to keep the population below a goal. From 2009 to 2011, there were 130 cow elk culled. And we stopped in 2011 because that's when we got below the 600 elk on the winter range goal. And you can see that the number has continued to fall into recent years. And that's why we're not doing culling, or we haven't done culling in recent years. And this might look alarming. You might be like, what is going on? Why is the population down? But we have to remember that this is just a snapshot in space and time, and elk herds are moving. And what we know from data from CPW is that this is largely a change in migration patterns, not a reduction in the elk population. And this is tied into this elk history that we've been talking about. Elk were removed from this area, they were hunted to extinction and then added back in from Yellowstone. And when we put them here, they weren't given a map or a GPS. They didn't know that there was this really nice area to the east that was much lower, a nice place to spend the winter. And so it seems like it took them close to 100 years to figure this out. And increasingly, now they're migrating down closer to Loveland during the winter. They come back up this time of year in the spring. They go into high elevation and then even into the Kawanichi Valley in the summer, and then they come back into the valley for the rut. This pattern, we think this is a big win because it spreads out herbivory across a much larger area. So what has that win, this reduction in the winter elk population, done for aspen and willow? So I'm going to just show you two figures. And these are a little, this is just pretend that you're looking down on all of our elk plot, or all of our all of our aspen plots. And these circles indicate the age of the tree, the size of the tree. Big green circles are big, older trees. And the issue with aspen was not that there was no aspen, it's that there was no new aspen. And that creates a situation where you can lose stands over long periods of time. On the bottom here, we're going from 2009 all the way over to 2023 in unfenced plots. And we see that there's been almost no change. We still have aspen, but it's only older aspen. And you can see a very different pattern in the fenced plots where they actually started off in worse condition, but we've had more and more recruitment from the small age classes into the medium and the large age classes. So this is exactly what we want to see, but we are not seeing it in unfenced plots. And we see a similar pattern in the willow data. So here, these are the baseline. This is a representation of the baseline data. Again, inside the fences, where we fences were in worse shape when we started. After 15 years, we've seen a large amount of growth on average, willow are 3 feet taller inside fences, and the cover has increased from 50% to 70%. But we've seen no change outside of fences. And you can see this really clearly with that image I showed earlier, or this. These are plot photos for when we're doing data collection. This is the same spot, believe it or not. And this is inside of a fence. So just a quick recap of what we've accomplished in 15 years of the vegetation management plan. We do have fewer elk in winter. We are protecting areas inside fences. We also monitor browse outside of fences, and we have seen that decline somewhat, but not nearly as much as we'd expect based on the reduction in elk in the winter. So kind of a mixed solution there. And then we want to recover willow and aspen, not just inside fences, but also outside fences. And there we have not succeeded. And the big reason we think is because of the arrival of moose in the park and their high population increase over the last 30 years. So many of you know that moose were moved to North Park, just west of the park, by CPW in 1978, 1979. It just took 1 year for them to first show up in Rocky. And CPW has continued to translocate animals across the state, and what we've seen is the classic eruptive increase in population, and the population has boomed statewide. And that is corroborated by just what we've seen in the park. Before, you could only see them on the west side of the park. Increasingly, they've come to the east side, and they've spread throughout pretty much all the watersheds on the east side of the park. They're just a more abundant animal that we see very frequently in the park. And the bottom line is that just the basic characteristics of moose makes them a challenge for wetland restoration. We still have an incomplete predator base to regulate their population boom and bust cycles. Hunting is illegal in the park, so we can't use that to regulate their populations. And unlike elk, willow is the primary food for moose. We know that from good research in the park that it's about 80 or 90% of their diet in the summer. And so because they're bigger and they really focus on willow, we've calculated that each moose is equivalent to 15 elk when it comes to the amount of willow that they consume in the summer. So this creates a situation where even a relatively small number of moose can have disproportionate impacts on wetlands in the park. So because moose were new to Rocky Mountain National Park, we started a research program in 2017 to answer just some basic ecological questions about moose. And one of the key tools we use is radio collaring. We've collared 58 moose through last year. And some of the things we're looking at are their movements. So here's a bull moose in purple and a cow moose in orange. So this can tell us some basic things like where do we expect to see herbivory impacts? When do they leave the park and could be subject to harvest by hunters? Stuff like that. We're also looking at their mortality rates, and when they die, we go and we try to determine the cause of mortality. We also can use the collar data to develop population estimation techniques. Sorry, I have to switch slides because I'll run out of time. Just look at that forever. Moose are tricky to estimate because they are dark animals. They don't tend to sit in these big herds, and they can be in deep cover. And so a lot of the traditional techniques work for them. Here, it's tough to see. We developed a pretty neat technique that uses aerial infrared to detect them easily. Here, we do it at a time of year where they're in velvet, and you can see that this is a bull. We piloted this in 2019 and 2020, and recently this was published. So if you're interested in details about this, you can Google Rocky Mountain National Park moose, and you'll find this. We found a density, so this survey wasn't of the entire park, and it excluded some key areas like Paradise Park and Wild Basin, which we expect to have pretty high densities. So we think this is a slight underestimate, but what we found is the density of 0.21 moose per square kilometer. I'm sure you're not good at thinking about partial moose per square kilometer. So to give some perspective, and we are going to repeat this survey for the entire park this summer. So you might see a plane flying early morning in July doing that. So to give that perspective, I'm going to show you moose densities from 2010 across North America. A couple of things to point out is you see this high density moose belt going through Canada, from Maine to Canada and into Alaska. The other thing is just how far south we are for moose, for the moose range. Colorado has the southernmost moose habitat. But then to put the densities into perspective, we are in this orange category here. So we're not the highest densities, but we do have densities that are similar to this moose belt in these colder areas. So I've talked about some of the key players in the history of wetland loss in the park. Now I want to zoom out a bit and talk about why wetland restoration is so difficult. And then I promise I will mention wolves at some point in a little bit. So to do this, I want to use this somewhat nerdy metaphor that ecologists use to talk about why ecosystems sometimes stay the same and sometimes they change. And this is called the ball and basin model. And what this describes is that ecosystems have natural feedbacks in them that maintain stability. Predation is a good example. This is very similar to how our bodies will shiver if we get cold or sweat if we get too hot. These are stabilizing forces that keep things the same. Similarly, this ball, if you pushed it, would come back to the bottom, right? So we're used to thinking about ecosystems as stable. Forests will stay forests, but we know that with enough disturbance, ecosystems will change. So here we know that wetlands, which have all these benefits I mentioned earlier, will change to a grassland ecosystem. And a key thing is that there's a threshold in here. And when you're on the left side of this threshold, the natural forces will push that ecosystem to a wetland. When you're on this side, the forces will push it towards a grassland. And so here we can talk, like what I've talked about is some of the disturbances that have pushed us towards this threshold. So this could have been removing the predators from this system. This could have been the trapping and loss of beavers from this system. And then maybe this is the aggravating effect of climate change. And a key thing is that if we stop right here, and maybe we do some minor restoration, the reinforcing forces in the ecosystem will naturally return it to a wetland. But where we think we are is somewhere right here, where we have crossed this threshold. And that means if we do nothing, if we do the thing that people often want to do, which is let nature take its course, we will lose these wetlands and slide down to a grassland state. So this metaphor can help us think about some of the key questions that people ask me all the time. Oh wait, real quick. We are this little tiny person, the Elk and Vegetation Management Plan, fighting against natural forces that are threatening to roll us over. But we are trying to hold back this ecosystem change. So people ask, when will fences be removed? When will these projects go on forever? Will we always have fences? Will we always be like nannies of nature? And this shows us that that is not true. All we have to do is do some of the hard work to get the ecosystem back over the threshold. Then we can let nature take its course and repair these wetlands back to the normal state. All right, so just some quick things about wolves. So yes, wolves have moved through the park for the first time in 100 years, which is super exciting for everybody at the park. We don't share locations of any collared animal or sensitive species. And you may have seen in the news that a female wolf did die in the park in April. It's under Fish and Wildlife Service investigation, and so no new information about that. And then people ask, how will we treat wolves in the park? And the answer is we treat them just like any other native species with the extra protection that a listed species enjoys. And then Doug talked a little bit about this, but there's just a lot of uncertainty. Wolves are idiosyncratic. They can act in different ways. So there's uncertainty about whether they will be living in the park in a way like they did in Yellowstone. We do have a lot of the key prey, and these elk, deer, and moose are the species that define wolf habitat. So there is that. But an interesting thing is that Rocky Mountain National Park was not identified as having quality habitat year-round in the research that was done for the reintroduction effort. And that's because most of our ungulates leave the park in the winter, with the exception of maybe a few elk and moose. So that makes it seem to me as an unlikely place to have a park-specific pack that lives in the park full-time year-round. But that doesn't mean we could have parks that use the park, packs that use the park. One thing we are pretty confident about is that the arrival of wolves is very unlikely to negate the need for some of the active management that we're moving towards. And to go back to this metaphor, that's because we removed wolves and then we waited for about 100 years, and a lot of things have changed during that time. We can't expect that we can flip a switch and the wetlands will restore quickly after that. The way I'd like to think about it is that wolves are critical to an ecosystem like oil is critical to the functioning of your car engine. We removed the oil, ran the engine until it seized. We can't expect to put the oil back in and have the engine work again. We need to do some rebuilding of the engine, and then wolves will help stabilize these ecosystems and keep us having healthy wetlands far into the future. So I'm at a lot of time. I just want to go over these key points that I hope that you walk away with. So the park has been and is losing its critical wetland habitat. We have made some progress, but it's really been limited to inside fences. Moose have arrived, spread throughout the park, and are exacerbating this problem. And we're studying these populations because we're moving towards making a new wetland restoration management plan that's very likely to include moose management. And just the last thing I'm going to say, well, I don't need to change slides, so we're good. The last thing I'm going to say is just remind you that these are critical ecosystems in Rocky Mountain National Park. It's a tiny area that supports a whole bunch of species. So we are engaging in this difficult work, but it's very worth it. And so we're going to be looking for your engagement as we move forward, and really appreciate you all coming out to learn about these ecosystems. Thank you. Okay,